Well, hi there. This is Mr. Kingsbury, and this is going to look a little different than some of my other videos because they weren't really official notes. I know that there were some things provided to you in the information we posted in the Google Classroom, but there have been some issues with solving quadratics, and I just thought maybe if I did a few examples, that would help you out. So I've got several examples. In fact, I have 7 of them, which I'll go through fairly quickly. Before I do that, I need to remind you of a couple things. So the whole point of taking a quadratic equation and factoring it or solving it is to figure out what values of x make the equation true. That's why we solve anything. If you'll recall, back in Algebra 1, when you first started to talk about factoring and understand what that was, you were actually reminded of polynomials. And it all comes back to this. If you have 2 binomials and you multiply them, what you end up with is a trinomial or a quadratic equation. Usually the best way to do this, or at least the most effective way that I've found, was to use the box method. So you put one of the binomials on the side, so 2x, 3, and then you put the other one on top, 4x, and 5, and you would do that because ultimately you need to multiply both of the terms in the one binomial by both of the terms in the other binomial. And this setup definitely allows you to do that quickly and easy. There's a lot of other setups. Some of you may have heard of the FOIL method. There's the distributing method. There's a long multiplication method. There's lots of methods. This one works well. I'm also going to come back to it later when I walk through what I call the Xbox method for factoring. There are a number of different ways. We'll get into that in a minute. So 2x times 4x. 2 times 4 is 8. X times x is x squared. And yes, I did change my pencil for those of you that noticed. Well played. 2x times 5. Well, we can multiply the 2 and the 5. That gives me a 10. I have an x here. I don't have an x here. So there's nothing to multiply the x by, which means it just stays x. Then we've got 3 times 4x. Once again, the 3 and the 4 are both numbers, so I can multiply them and get 12. And then, once again, I have an x here, but I don't have an x down here, so there's nothing to multiply this x by, so it just stays x. And then lastly, we have 3 times 5, which is 15. So what we have after we're done multiplying is 8x squared, 10x, 12x, and 15. And what we're doing, since they're all in the same equation, is we are adding them up. And the only other piece to this process is that these 2 in the middle here, the 10x and the 12x, those are like terms. So we can put them together. That means the 8x squared and the 15 aren't going to change. But 10x's plus 12x's ends up being 22x's. So when I multiply 2x plus 3 and 4x plus 5, I get 8x squared plus 22x plus 15. What we're going to talk about is the reverse of that. I wanted you to see this because what we're going to do is start with this trinomial here, and we need to end up with 2 binomials. Now, what you'll notice is in the quadratic, we have this quadratic term, right? This is our trinomial. We have a quadratic term. That's the x squared term. We have a linear term. And then we have what we call a constant. I'm just reminding you of the vocab. You should be old hat at this by now. I'm telling you this, though, because if you'll notice, this quadratic term is right there. It is something that I got from multiplying 2 terms straight out. Same with the constant right here. What changed, though, is the 2 things I multiplied to get my 2 linear terms became 1 linear term. And that's really the biggest challenge with quadratics, with factoring or finding a solution to a quadratic equation is at some point this 1 term was actually 2 other terms. That's the biggest hurdle we have to overcome is what were the 2 things that were combined to come up with this middle linear term. Once we figure that out, there are a number of ways to go about factoring. I'm going to show you 2. Probably on the first problem, I'll show you 2, and then I'll just stick with the box method for the remainder of them. So generally speaking, here's what we're going to do. And there's a long explanation for why this works. But what I need to remind you is that a quadratic equation standard form of a quadratic equation looks like this: ax squared plus bx plus c. And it's supposed to equal y. For us, we're going to make it equal 0. And by doing that, what we're looking at is specifically the x values that when plugged into this quadratic give us 0. And there's a whole graphic explanation about that where we go to a graph and we show that those are the x-intercepts, and we have lots of fancy names. That's not important for what we're doing right now. Here's the general process. It turns out that these two numbers here that add up to this middle number, if you multiply them, you get the same thing that you would get if you multiplied the coefficient of x squared, the quadratic coefficient, and the constant. So what we're going to do is we're going to multiply a and c. That's our first step, all right? So we need to multiply a and c. That gives us our product. Then we need to identify what we call our sum. This would be the b value right here. And then what we'll do from there is we will find two numbers. That means numbers. I know to you guys it means hashtag, but it's also the pound side. Yes, I'm old. Find two numbers that multiply to this and add to this. And I'll show you how to do that. There's a method to it that I will explain. Once you've done that, then you can use the box method or the group method to do some factoring. It usually involves greatest common factoring. So we'll go from there. But this is kind of our setup for the first part, right? So this is kind of part one. And then for part two, then you'll set it up somehow. Usually you have to find the greatest common factor of two different things. So part two, we'll call it. We'll either use the grouping method or the box method. All right? So keep those in mind. Let me just show you a few. So let's start with example one here. And I apologize if this takes longer than expected. I really don't want to make this a hugely long video, but I want you to see all the examples. Of course, you can do a little or as much of the video as you want. I'm certainly not going to be checking your notebooks for it or anything. Let's start with this. So we have 2x squared minus 3x minus 5, and it has to be equal to 0. Now, right now, what I gave you is already equal to 0, so that's awesome. That will not be the case on future examples. All right, so I call this the X box method because usually I use an X to find my two linear terms, and then I use a box to figure out the ultimate factors. And actually, we're going to be solving, so then there's another step. I probably should have added one more thing, a part 3, right? So part 2, use grouping or box method, right, to find the factors. And then part 3 would be set each factor equal to 0 and solve. Really, the last part is once you find the two middle linear terms, everything else is very simple. So let's go back to my example here. So step 1, I need to multiply my A and my C values. Well, it may be helpful if I identified them. A is going to be 2. Notice I didn't write 2x squared. A, I keep going back to this page, so I don't know why I keep turning it over, but A is the number next to x squared, not x squared itself. If I ask you what the A value is, or you're asked what the quadratic coefficient is, that's this number next to x squared. Okay? If you tell me that the A value is all of this, that's like me asking where the nearest hardware store is, and you just tell me the whole shopping plaza that it's in. That's not going to work. You can't say, oh, yeah, it's in University Oaks. No, that's a whole shopping plaza. That's not the hardware store. By the way, there's not a hardware store. I just couldn't think of another shopping plaza. Anyway, the point is, A is 2 in this case. B is going to be -3. Notice I included the negative in front of it. and then C is going to be negative 5. Now, truthfully, this is going to get a bit sloppy and all over the place at first because I'm going to go through a lot of detail, but eventually I'll slim it down, all right? So the reason I call this the X box method is because I draw an X, and I put my sum, which is negative 3, on the top, and then I multiply A and C. So A times C, that would be 2 times negative 5, which is negative 10. So I'll put that on the bottom. Now here's where we have a little fun. Eventually, if you do this enough, you get really good to the point that you can think through it in your mind, and you go, oh yeah, and you'll adjust signs, and you'll figure out what the two numbers are that multiply to negative 10 and add up to negative 3. Right now, though, we're probably not at that point. So we're going to list out all of the integer values that multiply to negative 10. Now, before I worry about the negative part, I'm just going to worry about the 10 part. So, for example, 1 and 10, they multiply to give me 10. 2 and 5 multiply to give me negative 10. 3 doesn't multiply by an integer to give me 10. It's like 3.3333 forever. That's not going to work. So we're going to ignore that. 4 doesn't work either. I think it's 4 times 2.5. I don't want to use decimals, so we're going to leave those off. 5 and 2, though, that works. And some of you now might be going, hey, Kingsbury, hold on. You have 2 and 5 and 2. Aren't those the same? Yes. And because multiplication is commutative, we don't need that pair. And that tells us we're done. When we get to a point where we're repeating what we're doing, we can stop. Now, you may notice that on the left-hand column, the numbers get larger in order. And on the right-hand column, they get smaller in order. I did that on purpose so I can keep track of my pairs. I want to make sure that I'm getting every single one and I'm not stopping until I found them all. This is a systematic and organized way to make sure I get every single one without missing any, and I don't stop until I repeat a pair that I already have. Once I repeat a pair, then I can stop. I'm good to go. Okay. Then I can go on to the next part. Now, I mentioned that this is actually a negative 10. And currently, if I multiply 1 and 10 or 2 and 5, I get positive 10. So we know we're going to have to adjust some signs. There are two things you need to consider, and you need to consider them in order, in this order first. The first thing you need to know is that the sum always has the same sign as the bigger number in the pair. That's another reason that I wrote my numbers out like this. All of the bigger numbers in each pair are on the right side. Whatever the two numbers are, when I added them up, I got negative 3. That means the bigger of the two has a negative. So I'm going to adjust my negatives here. Before you go on to the second piece, try a pair. So I'm going to try 1 and negative 10. If I multiply 1 and negative 10, right, 1 times negative 10 equals negative 10. Is this the same? If it is, you're done. You don't need to change any more signs. If it isn't, and hopefully I'll have an example of that and just down the line here, and I know this is already taking a much longer time than I wanted it to. If it isn't the same, then you change the signs on the left side as well. So first thing with signs, change the signs in the right column to match the sign in of the sum. And sometimes they will already match. Then do a check. If they're the same, you're done. If they're not the same, change the signs of the left. Next, then, we need to figure out which of these pairs adds up to negative 3. 1 plus negative 10 is negative 9. 2 plus negative 5 is negative 3. We need negative 3. So that would be 2 and negative 5. Now, truthfully, that's the hardest part of this whole situation, this whole process, is finding these two numbers. Once you have them, everything else falls into place pretty quick. So let me show you the box method first. This will be the reverse of what I did on the first page there. So I'm going to draw a box because we know that with quadratics, we'll end up with two binomials. This time, instead of putting stuff on the outside and multiplying to get the inside, I'm going to put stuff on the inside and hopefully get stuff for the outside. So this is my original problem. This, as I mentioned before, the quadratic term goes in the upper left-hand side, upper left-hand corner, excuse me. And the constant goes in the lower right hand with the negative. The whole point of what we did up here was to figure out what two numbers combined to give me negative 3x. Well, those two numbers were 2 and negative 5. And you can put them either place. It doesn't matter. Just make sure one goes here and one goes here. So we got 2 and negative 5. And you need to put an x after them because remember, it wasn't negative 5 plus 2 gives me negative 3. It was negative 5x plus 2x gives me negative 3x. What I'm saying is when they combine, we need a term that has an x, so they both must have an x in them in order for that to happen. And I know I'm talking a lot. I'm sorry. I'll try and go a little bit faster after this. Once you have all four of these plugged in, you pick one row or one column. That's a column or a row, doesn't matter which, and you find the biggest common factor, the greatest common factor. I tend to like to look for one where they're all positive. That helps. And certainly, I thought there was another piece of advice that I had. I can't think of it. If it'll come to me, I'll let you know. I like this row because they're both positive terms. That's one less thing for me to worry about. They both have a 2 and they both have an x. So I'm going to factor out a 2x. After you do that, the rest of this is simply division, honestly, but it's pretty easy division. What would I multiply 2x by to get 2x squared? Well, I don't need to multiply the 2 by anything to get 2. What would I multiply x by to get x squared? That would be another x. What would I multiply 2x by to get 2x? Well, that would be 1, right? 1 times 2 is 2, and I have an x, and as long as I'm not multiplying it by another x, it stays x. And then down here I can go, what times x gives me negative 5x? Well, I have the x part already. I don't have the negative 5 part, so that must be what goes here. And then here's how you check if you did a good job. What's negative 5 times 1? It's negative 5. Is that what is in my lower right-hand corner? It is. So that means then my factors are, here's one factor, here's the other factor. My factors are x plus 1. I put a plus because this is a positive 1. And then this is 2x minus 5. And remember, it still equals 0. So all of this was to show you how to get from 2x squared minus 3x minus 5 to x plus 1 times 2x minus 5. We need to break it into the two things we multiplied to get it so that we can solve. Now, I did say I was going to show you some other methods, but because time is going by so quickly, I see we're approaching 20 minutes already, and I've only barely done one example. I'm going to go ahead and finish it and then do a few more examples just to point out some things you might see. I will probably do them fairly quickly, but I'm not going to show you that other method. It's grouping. It's kind of cool. Most people seem to dig the box method anyway, so we'll go with that. You remember this was part 4 right here, and then I put part 5 was set your factors equal to 0 and solve. So you take each of these. This uses something called the multiplicative property of 0 or the zero product property. That's what it is. Ultimately, what that means is the only way that you can multiply something and get 0 is if one of the two things you're multiplying is 0. What I'm saying is you couldn't multiply like 1 times 5 is not going to equal 0. Or 6 times 2 is not going to equal 0. In order to get a 0, one of these has to be 0. So that tells us that either this is 0 or this is 0. That's the only way you multiply these and get a 0. So we set each of them equal to 0 separately, and then we solve them. So I'll solve over here. I've got x plus 1 equals 0. I need to get x by itself. I have a plus 1 on that side, so I'm going to subtract 1. I get x equals 1. Over here, I've got 2x minus 5 equals 0. Technically, you could either get rid of the minus 5, or you can get rid of the 2. I suggest getting rid of the minus 5 because it's easier, and people are less likely to make mistakes. If you want to get rid of the 2, that's fine, but to do that, you're going to have to divide, and you need to divide all 3 of these numbers by 2. See, with multiplication and division, you have to do that thing, that operation, to every term on all of the sides. With addition and subtraction, you simply do it once to each side. So typically, it's easier to cancel out the minus 5. To do that, we'll add 5 to both sides, right? Negative 5 plus 5 is 0. 2x plus 0 is 2x. So on the left side, I have 2 times x. 0 plus 5 is 5. Now I have 2 times x. In order to undo times, we need to divide. What you do to one side, you do the other. So we've got 5 halves, or if you like, 2.5 on the right. Over here, 2 divided by 2 is 1. 1 times x is x, so I get x equals 2.5. So that's pretty much the longest example that I'm going to do. It's got everything covered. I'm going to flip to the next page now and try and do a few more examples just so that you're not caught off guard when you see a few things. What you have to remember before starting is there are 2 rules. The first of those rules, and I'm going to tell you that with this next one, is it must be set equal to 0. I don't remember if I labeled the other one, but we'll call this example 2. So let's say that I got 10x squared equals 27x minus 18. Now, you may recall that on the previous example, it was set to 0 for us. This one is not. So what I'm going to tell you is we need to make this equal to 0. That means we need to cancel all of the terms on one side or another. Many of you may go, hey, there's only one term on the left side. Let's cancel that. I applaud your strategy and your thinking. That's excellent. I love that you picked up on that, and that's not a bad idea at all. I would like to suggest, however, that when working this method, having a negative a value, which is what this will be, is going to make your life really, really difficult. So even though there are 2 terms on this side, I would suggest canceling the terms on the right side. So first, I'm going to cancel positive 27x by subtracting 27x from both sides. Now let's just look at the right side for a minute. 27x minus 27x is 0. 0 minus 18 is negative 18. Please don't forget that that negative is there. A lot of people will do this. They'll correctly cancel that out, and they will write positive 18 here. That will throw everything off. Whatever the sign is here will end up here. This is minus 18. It must be minus 18 here. Now let's talk about the left side for just a moment. These are not like terms. Many of you are going to look at that and go, Miss Kingsbury, they got numbers? They got an X in them? I mean, what's the big deal? Here's the problem. This has a square. This does not. And the problem with math is you cannot put things together unless they're like terms. So the best we can hope for on the left side is to simply write out what it is we're doing, but instead of in a column, or write it in a row. 10x squared minus 27x. And it still equals negative 18, which we'll handle in a second. Remember, math is not just about solving. You are communicating ideas. You are showing your logic. You are writing a proof. This is our proof that x equals some value or values. So let's continue with it. I'm going to cancel negative 18 by adding 18, right? 18 positives and 18 negatives, they cancel out. The same thing goes on this side, because in order to keep things balanced, what you do on one side, you must do on the other. On the right side, we mentioned that 18 negatives and 18 positives cancel out. It gives me a big 0, right? One of the issues I see is people will be working this and they'll go, oh, I canceled it out. I don't know what it equals. It equals 0. The whole point is to get this to equal 0, first of all. And secondly, 0 is a number. So when you cancel everything out on a side like this, you write 0. That indicates there's nothing there. There's nothing wrong with writing a 0. And yet every year I get students that do this beautifully. It's a beautiful, fabulous, wonderful move, and I love it. And then they don't put 0 here, and they go, I don't know. And then they decide to put the equal sign somewhere else, and it completely changes everything. You can't do that. 0 on this side. Now back to the left side, we get the same problem we had before. We got 10x squared minus 27x, and we have to put minus 18 because once again, This is not the same as this or this. This is a constant, no x. This is a linear term, just an x. This is a quadratic term, x squared. However, you may recognize that, look, now we're like where we were at the previous example. We have an a value of 10, a b value of negative 27, and a c value of negative 18. So this will be a lot of fun. And if you need to go to desmos.com/calculator to get a calculator to help you, or use the calculator on your phone or on your computer, or use your fingers, that's fine. I probably will whip out my calculator here in a second, because what we're about to do is going to be kind of big. All right, so here's my x. My b value is negative 27. That goes on top. I'm going to multiply a and c. 10 times negative 18 is negative 180. I told you it was going to be big. There's going to be a lot of factors here. And I apologize, but I'm going to go through it kind of fast. So again, ignore that it's negative. What do we multiply to get 180? Well, 1 and 180, 2 and 90, 3 and 60, 4 and, I want to say 35, 4 and 45 actually. My bad. 5 and 36, 6 and 30. I know there's a lot, right? 7 and, just kidding, 7 doesn't go into that. 8 does not go into that, but 9 and 20 do. Notice the numbers are getting closer together. These are 179 digits apart, or units apart. These are only 11, right? We got 10 and 18. Now this is where people will stop. They'll go, "Oh, I'm done. I don't need to do anything else because I got them all." No, you haven't repeated any yet, so you keep going. Now 11 won't work. I don't believe 12. 12 does. 12 goes into it one time with, let's see, 1 and 5. I do believe that's correct. Excellent. Let's see. 13 does not work. 14 does not work. 15 and 12, and oh look, we just repeated. Now we can stop. And I'm telling you, if you didn't go that far, you wouldn't be able to get this right. Next up, we need to adjust the signs. My sum is negative. That makes the right column all negatives. Now let's pick one. I happen to like 3 and negative 60. If I multiply that, 3 times negative 60 is negative 180. That matches, so I don't need to touch these on the left side at all. I just need to figure out which of these adds up to negative 27. Now, there's a lot here, so if you want to go through and add them, you can. I promise you their sums will get smaller and smaller as we go down. This, we get 1 plus negative 180 is negative 179. 2 plus negative 90 is negative 88, and it keeps going. I'm going to skip a little. 6 plus negative 30 is negative 24. Uh-oh. We needed negative 27, right? Uh-oh. So it looks like I went too far. Maybe I shouldn't have skipped. So this is negative 53. Oh, do you guys see where I messed up? Wow, I really messed up. Forgive me. We added here, didn't we? And what did I do here? I subtracted. This should be positive, like that, which means I should have a positive 180. Ooh, that's interesting. So I need to backtrack for just a second. That changes things, and my apologies for leading you astray. This multiplication is still correct. These are all still negative. That doesn't change. What does change, though, is when I multiply 3 and negative 60, I get negative 180. I need positive 180. These don't match, which means I need to change the signs of all of my numbers there. Wow, I am really, really, really sorry about that. So now when I start adding, things are going to be a little different. Negative 1 plus negative 180 is negative 181. Negative 2 plus negative 90 is negative 92. Let's skip down a little bit. Negative 5 plus negative 36 is negative 41. All right, we're getting closer. I'm going to skip down to negative 9 plus negative 20 is negative 29. Negative 10 plus negative 18 is negative 28. Negative 12 plus negative 15 is negative 27. Now, I'm going to be honest with you. From here on out, I'm just going to go right to the pair. After I adjust them, I'm going to tell you what pair it is. You don't really need to go through all of this once your number sense gets really well developed. You start to have a feel for things and understand, oh, these are what the two numbers should be. Honestly, as soon as I got to 12 and 15, I knew that's what it was going to be. That's part of the reason I knew that this was a problem, and I found it. Anyway, so we have our two numbers, negative 12 and negative 15. So let's go to the box method. And we will put our, so remember we're using this, right? We're using this one that we adjusted, not this guy up here. And that's another problem that people have, is they'll pull their A, their B, and their C values out of this. It's not equal to 0. This one is. So I'm going to put 10x squared in the upper left-hand corner and positive 18 in the lower right. It doesn't matter which of these two, negative 12 and negative 15, goes in either box. There we go. Make sure you put an X after them. There's not a row or a column where they're both positive. So I'm going to go with the smaller numbers. They certainly both have an X in common. It looks like there's a 10 and a 12. So at the very least, they have 2 in common. If I divided 10 by 2, I get 5. That would be 6. 5 and 6 have nothing in common. This one's a little more advanced too. So, all right. So what would I multiply 2x by to get 10x squared? Well, 10 divided by 2 is 5. X squared divided by x is x. Basically, 5 times 2 is 10. X times x is x squared. Beautiful. What would I multiply 2x by to get negative 12x? Well, the x's are good. I don't need one of those up here. But what would I multiply 2 by to get negative 12? Or another way would be to say it would be what's negative 12 divided by 2. Obviously, 2 is positive, but I need a negative, so whatever it is going to be negative. And what would I multiply 2 by to get 12? Well, that would be 6. What would I multiply 5x by to get negative 15x? Well, I already have the x, so I don't need one here. What would I multiply positive 5 by to get negative 15? Whatever it is, it's got to be negative, so I get this negative here. And what would I multiply 5 by to get 15? That would be 3. And let's check. What's negative 3 times negative 6? That would be positive 18, which is what I got here. So my factors are 5x minus 6 and 2x minus 3. And those both equal. And those equal 0. And then we set them equal to 0 separately. So let's solve these. Here, I would add 6 to both sides. On the right side, I get 6. On the left side, negative 6 and 6 gives me 0. 5x minus 0 is 5x. So I get 5 times x equals 6. This is 5 times x. To undo times, you divide. We'll do that to both sides. So we get, on the left side, 5 divided by 5 is 1. 1 times x is x. On the right side, 6 divided by 5 would be 1.2. So there's one answer. Let's check this other guy out. We're going to add 3 to both sides. On the left or the right side, 0 plus 3 is 3. On the right side, negative 3 and 3 is 0. 2x minus 0 is 2x. This is 2 times x equals 3. Undo times with division. On the left side, 2 divided by 2 is 1. 1 times x is x. On the right side, we've got 3 divided by 2, which is 1.5. So that's something else that you need to be aware of. There's other things that you need to know about as well. So I'm going to show them to you. Just real quick, I want to point out that you may see it as a decimal. You may have also seen it as simply 6/5, and you may have seen it as 3/2. The maze that you're supposed to do that has all these problems, I'm pretty sure they're all written as fractions. So really all you have to do is leave it as a fraction like that instead of actually doing the division. I know you guys like decimals, so I did it really without thinking. I don't know that I'm going to have time to solve all of these, but I certainly want to show you a couple things as well. So I mentioned there were 2 things that you need to do before solving. This next one has the second one in it. Let's start with, let's do this. So we got 6x squared minus 18x equals 24. The first thing I mentioned was it must be equal to 0. It's not. So subtract 24 from both sides. 6x squared minus 18x minus 24 equals 0. The second thing, and I haven't mentioned this before, but I'm going to mention it now, is you need to make sure that there aren't any greatest common factors. And truthfully, I think I wanted to show you another one. I'll do that in a second, though. So I won't solve this all the way through, but if you'll note, I'm just looking at the coefficients here. 6, negative 18, and negative 24 are all divisible by 6. So if you factor out a 6, 6 divided by 6 is 1. 1 times x squared is x squared. Negative 18 divided by 6 is negative 3, and we've got an x there. And negative 24 divided by 6 is negative 4. You may recall we did some greatest common factoring. When you do that, this is still part of the mix. It's still one of the factors, but you don't need to worry about including it in all that solving stuff. So you know we went from these bigger numbers, 6, 18, and 24, to now technically 1, negative 3, and negative 4. Much easier to work with. So always, always, always set your equation equal to 0. And 2, factor out the GCF. You will still come up with the right answer if you don't factor out the GCF, but it will take you longer and it will be harder because you will be dealing with much larger numbers, which means you will get more factors when you do your x factor over here, or you're factoring on your x part there. It saves you a lot of time and trouble. All right. There's really only one pair of numbers that multiplies to 4 and adds up to 3. 1 times 4 would be 4. Anyway, it's a lot fewer numbers to consider than if we had to multiply, say, 6 and 24 or 6 and negative 24. So just keep that in mind. All right. I wish that I had time to work that out for you. If you want to try it, the answer to that one is x equals negative 3 and x equals negative 6. You don't have to, not a big deal. I'm just noting that this video is going on for a really, really long time, and I'm sorry for that. So there's just a couple more that I wanted to talk to you about, things that I wanted you to see. I'm not sure why I have this one in here. That's weird. Oh, no, I know why. Okay. I gave you the wrong answers, by the way. Sorry. The answers to this were 1 and negative 1. X equals 1 and x equals negative 1. My apologies. I was looking at the next one I want to show you, which is this. X squared minus 3x minus 18 equals 0. So note, already equal to 0, right? That's good. And I'm pretty sure you guys could look at this and go, well, clearly B is negative 3 and C is negative 18, right? That's easy. But you will go here, and a lot of people will go, I don't know. Because I was really, really loud and explicit about the idea that it was the coefficient of x squared. But there's no number here. Remember that mathematicians decided if your coefficient is any other number besides 1, you have to write it. But if there's just 1, if the coefficient is just 1, it's implied. So if you don't see a number in front of, that was my cat. He was trying to get in the shot, and I was pulling him off the kitchen table. Sorry, Scout, you cannot be in this video. If you have a term like this, or just an x, and there's not a number written explicitly in front of it, assume that it is 1. So then we'll go over here, and that's really the reason I wanted to show you this, is if you run into a case where you don't have an explicit coefficient. So 1 times negative 18 is negative 18. My sum is negative 3. What are all the things that multiply to give me 18? I'm so glad you asked. 1 and 18, 2 and 9, 3 and 6, 4 doesn't work, 5 doesn't work, 6 goes to 3, so I don't have to repeat it. I'm going to go a little faster now. My sum is negative, so the right side must be negative. If I multiply 1 and negative 18, I get negative 18, so I don't need to change the ones on the left side because I got the product I needed. The question is which of these adds up to negative 3, and that would be this one. 3 plus negative 6 is negative 3, so we put that here and that here. Now we will draw our box, right? X squared goes here, negative 18 goes here. I'm going to put the 3 here and the negative 6 here and put an X behind them both. I'm just going to look at the first row. They both have an X. That's the only thing they have in common. They don't have any numbers or coefficients in common. What would I multiply X by to get X squared? Well, that would be X. The nice thing about these problems where the coefficient, the quadratic coefficient, the A value is 1, the box part goes really quick. Okay, what times X gives me 3X? That would be 3. What times X gives me negative 6X? That would be negative 6. Negative 6 times 3 is negative 18. That's what's in my lower right-hand corner. So I have X plus 3 times X minus 6 equals 0. I will set each of them equal to 0 separately. Here's the other nice thing about these. There's only one step for each. Here I would subtract 3 from both sides, so I get X equals a negative 3. Here I would add 6 to both sides, so I get X equals 6. Cool. So there's that. I was going to show you an example where it kind of combined the thing not being equal to 0 and also not having a quadratic coefficient other than 1. I didn't say that very well, but I hope you understand. We're going to skip that because I think you can put them together. I did want to show you this one because something interesting happens. I don't remember what example we're on. I think we're on example 5. So we got 7x squared minus 14x equals negative 7. It's not equal to 0. So I don't know where I was going. So I need to make it equal to 0, right? Absolutely. So I'm going to add 7. Whoops. I'm going to add 7 to both sides, not 6. Right here. Remember, these are not like terms, any of them. So I'm just going to write 7x squared minus 14x plus 7. And then on the right side, those cancel out and I get 0. That's what I wanted, right? Then the next thing I'm going to want to do is check it for any kind of common factors. So let's see what we got going on here. Let's see. 7, negative 14, and 7. Well, it looks to me like all of those are divisible by 7. So I'm going to factor a 7 out. And I'm going to do it kind of quickly. I get 7 times x squared minus 2x plus 1. This is going to be ridiculously simple to factor, promise. Ignore the 7 on the outside. So A will equal 1, B will equal negative 2, C will also equal 1. Something interesting is going to happen here, and I'll talk more about it in a second. 1 times 1 is 1. Negative 2 is my sum. There's only one thing that multiplies to 1, and that's 1 and 1. There's nothing else. So that's all I have to list. However, the sum is negative. And if I multiply 1 and negative 1, I get negative 1, not positive 1 like I need. So I'm going to have to change this sign. Now, negative 1 times negative 1 is positive 1. And sure enough, these add up to negative 2. So I can draw my square, right? We've got x squared goes here. We've got 1 that goes here, and then I'll put negative 1x and negative 1x. All right, and I'll just pick the top row here. What do they have in common? An x, that's it. What times x gives me x squared? That would be x. What times x gives me negative 1x? That would be negative 1. What times x gives me negative 1x? That would be negative 1 again. Negative 1 times negative 1 is positive 1, which is in my lower right-hand corner. So my factors are x minus 1 times x minus 1. And I'm supposed to put both of those equal to 0. And some of you may be going, wait a minute, Kingsbury, those are the same. You're right. They are. And if you end up with something where you have the same factor twice, you only have to solve it once. Let me prove it. If I add 1 to both sides here, I get x equals 1. If I add 1 to both sides here, I get x equals 1. So that's not bad. You'll notice that they're the same, so you really only have to list it once. This was unnecessary. Right? Totally unnecessary. All right. So I'm just about done. I did want to show you one other one, just really quick. it actually has nothing to do with solving by factoring using the Xbox method. Here is the last one that I wanted to show you. It's 7x squared plus 2x equals 0. Now, remember what I said? I said before you can solve any quadratic, it must be equal to 0, and you should factor out any common factors. Well, this is already equal to 0. And right now you must be going, but Kingsbury, there's only two terms. There's a quadratic term and a linear term. There's no constant. You're right, there isn't. This makes our job ridiculously simple. So the first thing is it must be equal to 0. Check. The second thing is factor out common factors. Well, guess what? They both have an x in common. 7 and 2 don't have any numbers in common bigger than 1, so we can't factor out anything there. But what we can do then is factor that x out, right? So the 7 doesn't change. X squared divided by x is just x. The 2 isn't going to change, but look, x divided by x is 1, right? So another way to look at this would be 2 times 1 is 2. Well, we have two factors now. Notice there's no square in here. In fact, we've gotten rid of the square. That's the whole point of factoring. All we have to do is set these equal to 0 separately. And look at this. There's nothing to solve here. There's nothing else on the same side as the x. That's already solved. And then this one, you subtract 2 from both sides. You get 7x equals negative 2. Divide both sides by 7, and you get x equals negative 2 sevenths, or whatever the decimal equivalent is. It's pretty nasty run on decimals, so I'm not going to do it. I just wanted to show you that because you might run into something so much easier than all of this. I appreciate your time. That went on about twice as long as I intended it to. Obviously, you can stop at any time that you want, but if you need help, please come back. Hope you're having a great day, and I'll talk to you later. Bye.